Hello, my name is Kenneth. Currently, I'm a student of mechatronics at the University of Technology, Malaysia. So for assignment 2 for embedded control systems, we were to implement PID control on the mobile robot. So for our PID control, we make use of the PID V1 library. We start by initializing our enable pins A and B and our inputs 1 to 4. Our two encoders, one on the left motor, one on the right. Then we set up two channels, which we're going to use to modulate the PID, channels 1 and channel 2. Then a frequency of 1000 and a resolution of 8. So in our code, we had also set up two counters, counter 1 and 2 for the left motor and right motor respectively, and two variables, one to get the speed of on the left motor and the right motor. And because we're using disk encoders of 20 slots, we had also set up a variable disk slots of 20. We had set up an interval of 1000 and current time and previous time variables as well. So for PID control using the PID V1 library, we are meant to initiate the following variables: the set point, input, the output, which are going to be used to control the PID for each of the motors. So because we're having two motors, we set up two instances of PID. I want to be the right PID and the left PID for each of the different motors. And for the different PID instances, we have different gains, that is a different KP, KI, and KD as illustrated. So to read to get the speed for each motor, we had set up two interrupt functions as illustrated. So I'm going to proceed to the setup function where we actually set up the set points for each motor, that is the set point speed we want the motor to be running at. So we have the set point and set point 1 for left and right motor respectively. We set them at 100 RPM, and we set up PWM channels as I talked about earlier, channel 1 and channel 2 with the same frequency and resolution. Then we attached channel 1 to enable pin A and channel 2 to enable pin B. We also set the mode for tuning the PID as per the library to automatic, such that it can so as I talked about earlier, our PID instances require one of the variables to be input. Yes. So for our left motor, we set up the input to be the left speed, and for the right motor, we set up the input to be the right speed, as you can see in the code. Then go on to calculate the speed of each motor as illustrated, and we set up the serial prints such that we can be able to plot them on the graph. So after setting up PID, now for the library to actually calculate the output, we call the function .compute as illustrated on each of the PID instances. So left PID.compute and right PID.compute for each of the two motors respectively. We then write the output of the instances. The left PID, we write it to channel 1, and the second PID instance to channel 2, which are going to be written to the different motors as illustrated. So to illustrate PID control, I'm going to connect our mobile robot to the code. Try to plot the PID control now for each of the motors to illustrate the PID control implemented. So this is an example. This is the mobile robot developed. I'm going to illustrate PID control on this mobile robot. each of the two motors we've set up PID control, and I'm going to try to plot that out. So I'm going to be illustrating the PID control on both motors. As right now, we've not yet supplied power to the motor, and we've set up the set point at 100 RPM. So initially, as we can observe from the graph, the motors are trying to follow the set point. However, like for the right speed, it's illustrated in blue. You can see it's fluctuating about the set point, having some level of undershoot, then overshoot, similarly to the left speed. But you can see that they're trying to follow the actual gain set earlier in the code. So I'm going to modify so that we can be able to have a faster response. So initially, our proportional gain for the right speed was 5, and the integral gain was 0.24. And on the left speed, we had set up proportional gain at 5 and integral gain at 0.21. This is our graph from earlier when both motors were running. You can see that for the left speed, it tries to adhere to the set point. However, it has some minimum level of overshoot. Right speed, we can see that there is some level of undershoot, then as it tries to adhere to the speed. So I'm going to try to modify the integral gains for both motors, and thereafter I'll be able to monitor progress and see what happens. So to minimize undershoot, I've increased the integral gain on the left PID from 0.21 to 0.25 as illustrated in the code. And now we're going to observe what happens for the PID control. So we're now going to observe what happens for So now we're going to test out the new gains on the motors to see how they respond for PID control. So as you can observe on the graph, we still have some amount of undershoot on the right motor. However, on the left motor, we seem to have a more consistent adherence to the set point. So that means perhaps the undershoot needs to be eliminated by increasing the integral gain on the right motor. So I'm going to pause now. So as I've illustrated, being able to create a PID control, maybe need some fine tuning, but at least we've been able to demonstrate that the motors follow PID control, trying to follow the set point as illustrated.